Rebound effects occur when improvements in technology that make resource usage more efficient eventually result in higher total consumption of that same resource. This seems counterintuitive initially, as the goal of increased efficiency is typically to reduce resource use. However, by making the use of a resource cheaper or more convenient, people may end up using it more, offsetting the original gains. Known as the Jevons paradox, based on William Stanley Jevons' work on coal use in 19th century England, this effect highlights the complexities and unintended consequences that can arise in the quest for sustainability. A classic example is the introduction of energy-efficient lighting technology such as LED bulbs. These bulbs consume significantly less electricity than traditional incandescent bulbs. However, because they are cheaper to operate, individuals and businesses may leave lights on for longer periods or install more lighting, offsetting some of the efficiency gains or even potentially leading to greater total electricity consumption. Thus, while each bulb uses less energy, the overall energy savings might not be as great as expected or hoped. Rebound effects intersect with various topics, including economics and the demand for information technology. In terms of economic impact, when efficiency improvements lower costs and stimulate demand, they can also drive increased consumption and production, sometimes leading to greater environmental harm. This underscores the interconnected nature of the economy and environmental health. In the sphere of information technology, for example, as data centers become more energy efficient, the cost of digital services may drop and the demand for them may escalate, potentially weakening the expected energy savings. Rebound effects spotlight the need for holistic approaches to resource conservation that integrate technology without inadvertently escalating consumption. The rebound effects in digital communication illustrate how efficiency improvements can lead to increased overall resource use. Initially, email promised to reduce paper consumption and the environmental impacts of physical mail delivery. However, research shows that the convenience and near-zero cost of sending electronic messages has led to an explosion in communication volume. This volume offsets at least part of the overall environmental benefits of digitization. Indeed, the unintended consequence of making communication nearly instantaneous and essentially free is that people now send hundreds of emails where they might have sent a single letter, creating digital storage demands and server energy usage that may collectively exceed what the technology was initially expected to reduce. In exploring rebound effects further, we can examine less obvious examples across different sectors. In industrial manufacturing, more efficient production processes often lead to lower prices, which can stimulate higher overall consumption of goods. In digital media, the transition from physical books and DVDs to ebooks and streaming services eliminated material resources but created new environmental impacts through increased device turnover and data infrastructure demands. In agriculture, water-saving irrigation technologies frequently result in farmers expanding their irrigated acreage rather than conserving water. These diverse examples show that efficiency gains often change behavior in ways that partially or fully counteract environmental benefits, suggesting that technological solutions alone may be insufficient without corresponding adjustments to economic systems, policies, and social norms.